multiples. Okay, so number one, anyone want to shout out what number one is? Yeah, electrons. Okay, so you can write the full word or E minus. Okay, that's the same thing as writing electrons. Whatever you are more comfortable with writing down. Okay. What about number two? What is number two?
Neutrons.
Yeah, neutrons. Number two is neutrons because it's pointing. Yes. Wow, what a scholar. Okay, it's pointing to this gray one right here with no positive or negative. So this is going to be the neutrons. They're going to be neutral. And you guys should have seen that neutral means no charge. That was one of the questions on your assignment last time. And then number three, the positive one is obviously going to be protons. Okay, so just keep those three things in mind. So this week, this is kind of the depth that we'll be going, but starting, I think, next week or the week after, we're going to start going into more detail about how to draw the atoms. And so you'll want to know how to do these three, know where they are, because it'll be helpful going forward. Okay. Okay, so like I said, you're going to need a periodic table basically every day for the rest of the year. So let's go to the periodic table and let's figure out which element has 16 protons. So protons are the number that's on top. So yeah, which one has 16? Yeah, sulfur. You just look for the element that has 16 on the very top. Sulfur has the number 16, so sulfur is going to have 16 protons. Good. Okay, so we would just write, you can either write just S, or you can write the full name, sulfur, whatever you are more comfortable with. Okay, so I'll give you guys 30 seconds to find copper on the periodic table, and then finish up number 5 on your own, and then we'll go over it in 30 seconds. Just a heads up, it is not CO, so just make sure you're careful about that, okay? Copper is not CO. All right, just write on your paper. We'll go over in a second. You guys are too fast for me. Alrighty, guys. So we had a little spoiler there, but if you guys look at copper on the periodic table, it's Cu. It's in the middle. It has number 29 on the top, so copper is going to be 29 protons. Okay. So that's what we learned last time. Any questions on any of this? Hopefully it wasn't too bad. Okay, so last time we met, we talked a lot about protons, right? We talked about the number on the top being the number of protons. Now today we are going to be talking about the neutrons and how they determine different things about the atom. Now, unfortunately, there's going to be a little bit more math this time, so I'll apologize in advance. But if you can do addition and subtraction, you should be fine for today, okay? Can you guys do 3-digit addition and subtraction? Yeah? No? All right, well, there's a calculator. You can use calculators in this class, okay? All right, so let's go on to talking about neutrons. Now, neutrons determine something called an isotope, as you can probably tell by the name of the lecture. Okay, and so I want you guys to write the definition of an isotope down. Okay, an isotope is a different form of the same element. Okay, an isotope is a different form of the same element. Okay, and another easy way that you guys can think about isotopes when you guys are comparing different atoms, it's going to be the atoms with the same number of protons, but it's going to have different neutrons, okay? So when you're talking about two isotopes, you're talking about something with the same number of protons, but different number of neutrons, okay? Same number of protons, but a different number of neutrons. Okay, now you guys might be thinking that probably isn't probably going to make a big difference, right? Because it's still the same element. So I'll give kind of an extreme example to show you guys how just changing the number of neutrons by a little bit it's going to have very different effects on how that element or that atom and its characteristics. So you guys might have heard of uranium before. It's what we use in nuclear reactors. It was what was used to make the atomic bomb. Okay, but uranium, there's two main types of uranium. The first one is uranium-238, and you guys don't need to write this down. I'm just giving you a quick example. You're gonna have to write down stuff in a sec. Uranium-238 is the most common form of uranium, and if you go outside and pick up a rock, chances are there might be a little bit of uranium-238 in it. So you can kind of see that it's very stable, right? You're not really scared of picking up a rock. Maybe somebody hitting you with it, yeah, but not the stuff inside of it. Okay, however, you change the number of neutrons, you get uranium-235. And uranium-235 is radioactive. If you hold it, you'll most likely die. If it's a very small piece, it'll give you radioactive poisoning. You might get cancer later on in your life, and we use it for nuclear fuel. So they're completely different in terms of their characteristics, but they're still the same element. The only thing that's different is the number of neutrons, okay? So let's figure out how many protons and neutrons there are and what the difference between the two are. So I want you guys to find uranium on the periodic table. It's going to be on the very bottom. And if you find it, can you shout out how many protons there are? Yeah, 92. You go to the very bottom of the periodic table. Uranium has the number 92. So both uranium-238 and 235 have 92 protons. So write that down for me on your notes. Okay, uranium-235 has 92 protons. Uranium-238 has 92, and 35 also has 92. Okay. Okay, so like we said, protons are going to be the same for different isotopes. Since it's uranium, it's always going to be 92. The only thing that changes are the neutrons. Now, in order to find the neutrons, what we're going to do is we're going to use a number at the very back. This number back here at the end of the names, this is called the mass number. And you're definitely going to want to write down this formula because this is what you'll be using for pretty much your entire assignment today. Okay, the mass number, the number on the very back, is going to be equal to the number of protons plus the number of neutrons. So the number on the very back of the isotope name, 238, 235, it is equal to the number of protons plus the number of neutrons. Okay, so like I said, if you can do 3-digit addition and subtraction on a calculator, you should be okay for today. Okay, so we'll do one together, and then I'll have you guys try the second one on your own. Let's do uranium-238, okay? So like we said, 238 is the mass number. So 238 for uranium-238 is equal to the number of protons. How many protons do we say that uranium-238 has? Yes, right here, 92. And then we're just going to add that to the number of neutrons. So we're trying to find the number of neutrons. So what should you plug into your calculator to find the number of neutrons? Yeah, very simple. You can just do 238 minus 92. Okay, it's just the reverse. Because you're trying to figure out what plus 92 is 238. So you can go to your calculator. And again, I'm cool with you guys using your phone calculators for your assignments. On the test, I'll give you a real calculator. But 238 minus 92, and you'll get 146. Okay, so uranium-238 has 146 neutrons. Oh, I have them in a box. Do you need one now? I'm sorry. I'm not a shooter. I am a dunker. Okay, so I'll have you guys try the number of neutrons for uranium-235. Give you guys maybe a minute. This should be a pretty simple operation. There's a long way to do it and a short way to do it. Doesn't really matter. I'll see if you guys can figure out the short way, but I'll give you guys about a minute to try figuring that out. All right, and check with the person next to you. Scholar. Who is this man? Yeah, A. I can see it. Like I said, it was never a matter of ability. Yeah. What's that? Oh. Um, Thanks. Alrighty, guys. So what did you guys get for uranium-235? How many neutrons does it have? Yeah, 143. Same. You can use the same process. You could have either done 238 minus 9, or sorry, not 238, 235 minus 92. That's totally a valid way to do it. Or you might have noticed 238 is just 3 more, right? So you can just take away 3 from 146 and you get 143. It doesn't really matter how you get it as long as you got the correct answer. Okay. All right, we'll do a couple more examples of this just so that you guys can get used to it. Now, I want to differentiate some of the ways that we write the names of the isotopes, okay? So you're going to want to do this on your paper. But you guys see this form right here, right? Where you write the full name dash the mass number. This is called the isotope name. So if you're ever asked, hey, write the isotope name, you got to write the full name dash the mass number, okay? The second way that you can write it is called the isotope symbol, okay? And this is the way I kind of like it just because it's a shorter way of doing it. You just write the symbol and then you put the mass number on the top left. Okay, make sure you put on the top left. Something else is going to go on the top right, so don't switch them because then you'll confuse whoever's reading it. And by whoever's reading, I mean me, and I'll mark it wrong on your test. You'll confuse the person reading it. Just make sure you put the mass number on the top left, okay, not the top right. Okay, so we'll do the magnesium one first, and then I'll have you guys try neon, okay? So magnesium, pretty simple. You just look for it on the periodic table. It's going to be on the far left. Let's find the number of protons. Yes, 12 protons. Magnesium has a 12 on the top. So we're just going to put that it has 12 protons. We want to find the number of neutrons. Now, we said earlier that the mass number, the number on the back, is the number of protons plus the neutrons. So 12 plus something is going to equal 26. So you can do 26 minus 12. That'll give you an answer of 14. And then for the isotope symbol, all you got to do is put the mass number, this one right here, 26, on the top left. And you can write the symbol for magnesium, which is Mg. And there you go. That's basically what you'll be doing for the majority of your assignment today. Okay. You'll either get the name, the symbol, the protons and neutrons, and you just kind of mix and match and try to figure out the missing parts of the isotope. Okay. All right, you guys think you could try one on your own? Yeah? Yeah. Okay, I will give you guys maybe a minute and a half. You can work with the person next to you. Use the periodic table to figure out the rest of this information about 19Ne. Okay? So I'll give you guys about a minute and a half to do that. Okay, so for 19Ne, we got to start with the protons. Super simple. Just look for Ne on the periodic table. All the way on the right, you got neon, and it's going to have 10 protons. So we're going to write that it has 10 protons. Okay, this 19 here is the mass number, so it's going to be the protons plus the neutrons. Should be pretty simple. 19 minus 10 is 9. Okay, and then for the isotope name, you just needed to write neon 19. Okay, easy peasy, right? Yeah. Sure. No, this is about as hard as it gets for isotopes. Yeah, I can't really make it more complicated. I can, but I don't want to do that to you guys. AP Chem. Oh my God. AP Chem goes over what we're going to do this whole year in about a month. About a month, yeah. They took their first test yesterday. It's true. All right, let's move on to some other practice problems. Okay, so on your assignment for today, you're going to have to fill out a table that looks like this. Okay, so I'm not gonna do both of them with you guys. We'll just do this one right here. And so you guys don't need to copy down the table. You can just write number 3 and just put in your answers, just kind of in the same orientation. That way you can check your answers with me when I'm going over it. But I'm gonna give you guys about 3 minutes. You can work with the person next to you. But just try filling out the rest of this table while working together. Okay, the only information I give you is the isotope symbol. I want you guys to figure out the isotope names, protons, neutrons, and electrons. And same thing as last time. Just assume that the atom is neutral for today, okay? And if you forgot what that means, you can look back at your old notes, but assume the atom is neutral. So I'll give you guys 3 minutes to try that out, and then we'll go over it, and then we'll be done for today. Assignment. All right, so you got the isotope symbol, and you guys can figure out everything else from that. So Ag, what's the elements for Ag? Silver, yeah, kind of confusing, right? Ag is silver. Okay, but it's going to be silver dash 100 and silver dash 105. That's totally fine. Oh, no, for this, the name, no. The name, you got to put dash and then the mass number. Yeah, thank you for clarifying that. Okay, so make sure that for the name, you do the full name dash the mass number, okay? Yeah, science, chemists are very specific about how you write the notation, so you got to keep it that way. Okay. All right, let's go to the number of protons. So you just look for the number on top of Ag. How many protons does silver have? Yeah, 47. That was really quick. Okay, and since they're both silver, it's going to be 47. Okay, now, before we do the neutrons, we can actually figure out the electrons. We said that it's neutral, so that means, yeah, they're going to have the same number of protons as neutrons. So we're going to put, or electrons. So we can put 47 for both of them. Yes. And that's what you guys should have answered for one of your questions on last time. Neutral means same protons and same electrons. All right. And then we'll go to the neutrons. From here, it's the simple math equation. You can just do 100 minus 47. And then you get 53. And then for this one, you can do 100 minus 47, or 105 minus 47, my bad. Or you can just add 5 to that. And then you can get 58. Okay? Yeah. Yeah, I would recommend putting in the formula, but I won't dock you if you like only do it for like one of them, as long as you know how to do it. Yeah, good question. Alrighty, well, I'll give you guys the rest of the class period to work on that assignment. I have the answer key if you guys want to check your answers at any point. I don't know if you guys noticed, but we do check for correct answers on the assignments. So you guys might have got like 4 out of 5, 3 out of 5, even if you finished. So make sure you guys check with me before you turn it in. I do want to mention, don't turn in your notes because you're turning that in all together at the end of the unit. So keep them in a safe place. Only turn in your assignment. Okay, and if you have your homework from last time, make sure you guys turn that in as well.